And I'm recording. Drop your name in the chat. Thank you. All right, guys. Are you ready now to tell me how to solve this? Who is going to volunteer? Do I have to call on anyone in particular? Because I will do that, If I'm not getting any response, I'm going to call on someone. This is your tutorial, not mine. Right? So I see I have Mr. Butler here, Antoine Butler, Mr. Christian Bennett, Javine Even, and you have Javon Barrett. You have Carl Wellington, Kevin Young, Malchik, and you have Nathan Edwards, Shamar, you have Shamor Williams, Shamar Tracy. So we have Shimar and Tracy, and we have Shamar Tracy. Who is going to volunteer now? Nathan, you are going to volunteer. I see your mic is open. Nathan? Hello? Y'all not hearing me? Butler?
I can hear you, sir.
Right, so why you guys not talking to me? What happened? You don't want to work the problem? Want to expect me to come and work the problem every day? No, 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 no. That's gonna change, right? That's not what the tutorial is for. Tutorial is for you to come and demonstrate some understanding, and then I can be there to help you and guide you, right? So for some of you who don't understand tutorial is not for the lecturer to really. So I've actually break your bad by coming and working the problem, but that's not how it's supposed to be done, right? So I need
Sir, we
your
will start off.
participation, whether it's online or not. I want your participation.
So we will start off finding the sum of fx and the sum of fy.
Uh, so you already know, sir.
Oh, sorry, I'm a different person.
Who is this now?
I'm Malachi.
Uh, Malachi.
Yes, sir.
Oh, uh, oh, okay. How
So,
you pronounce your name?
so, so,
Malachi?
yes, sir.
Okay, all right. All right. So you are
So,
going to tell me how it's done. And I'll write, if you so, what your statements that you put down. So I'm ready to write.
so I will start off by finding the both of the sums of fx and the sum of fy.
You have to talk loud, let me hear you know. What you say now? Come again.
So I will start off by finding the sum of fx and sum of fy, sir.
Sum of fx, and sum of fy.
Fo. Yes, sir.
Mm-hmm.
So I will
Mm-hmm.
start off first. Since the weight is 10 kilograms, I would say 10 kilogram, well, negative 10
So what
because
you do? You
the
draw a
30.
free body diagram already? Did you draw a
Oh,
free body
sir,
diagram? So
yes, sir.
okay. All right, let me draw the free body diagram. Let me draw some free body diagram. Where is my tool? I want some lines. All right, so let me draw a free body diagram, and then we take it from there. So this is the right thing. Always draw a free body diagram, right?
Yes, sir.
It's thousand. A picture is worth 1,000 words. That philosophy. And so let's go again. Need to draw this one here. Um, I'm gonna draw that one there. Okay. All right. So pretty much we can do some writing now. So we could say that this is uh theta, and this is 30 degrees. Okay, and we do some labeling. This part here is C, and this part here is A. All right, and this part here is B.
All right, so since CA is in the negative quadrant of x, I would say negative 10 cos the angle 30 because
All
negative
right.
x is adjacent
Well,
to
I'm gonna
30.
write it, you know. I'm gonna write. So take time with me. See which one you're gonna write first. Which expression you're going to write first. We're
So
gonna do
negative 10
some of the forces in the x.
fx.
You're gonna start with x
Yes, sir.
first.
Yes, sir.
Okay. Mm-hmm.
And since CA is in negative x quadrant, I would say negative 10 cos the angle, which is adjacent to it, is 30. So negative 10 cos 30.
So okay. You notice how I label these? You can label them like that. Let me clean up this one. You can label them like that. That's the correct way to do it. All right. So you can label them C, B. All right. So those are the tension. And what about the weight going down? We need to label this one too. Just before you go any further. So what's the weight equals to? So it's 10 times 9.81. Everybody got that? This is
Oh, yeah, so that's
98.1
empty.
is the amount Newton going down because mg, force is equal to mg. Right? So that tension there is really equal to 98.1. Did everybody figure that one out already?
Yes,
And
sir.
Yes, sir.
this is 40. The angle here is 40. So we can actually take out the theta.
Excuse me, sir. My internet tipped off for a sec, so I missed a bit of that. Could you go back a
But
little bit, please?
I don't do anything. The young man is going to explain to us. The person who is going to explain to us. I'm just labeling. I'm just labeling this, All right. Um, your classmate. So actually doing this part for you. Can you do your free body diagram first? Because if you don't have a good free body diagram, then you know. So that is essential what we're doing there. So I did that. All right. So you must recognize all the forces that you have, and you can put in your arrow. That one going that way. Um, let me just do something here. Give me a second. I'm going to just fix something here. I'm going to change the color of these just to show you the force line. All right. That's just the force line. Ah, that one is off. That one is off, man. All right. I want to try and fix that again. All right, so there we have it. I'm ready to write again. Um, yeah, tell me what to write now, sir. Which are you gonna start first?
So I'm starting from the X, sir.
Mm-hmm. Yeah. So which one are you
Right.
going to write first now?
So I would say negative 10 cos the angle 30.
Negative. Hold on. Something is uh, negative 10. Where you get
Yes,
10?
sir.
Where you get
Sir,
10?
I just work with the kg first and afterwards I times it by
All right.
the gravity. Is that
Before you
wrong?
start, work with
Or
the
should I?
work with this with symbols. So you remember, you're trying to find the tension. So you have to draw your free body diagram. What are the tension that you're trying to find? It's T, C, A, and T, C, B. Isn't there those two things that you're trying to find?
Yes, sir.
Mm-hmm. So think about it. You need to resolve the forces in the x directions, right? And make a statement. Now, if the body is in equilibrium, we could say that some of the forces in the x's must be zero. And similarly, so those are zero, those are zero. All right, so that's supposed to give you a hint now. I'm ready when you're ready to go when you are. Ready to write when you are. And other persons can participate, doesn't mean one person. You ready again?
Give me a second, sir.
Resolve them to the which quadrant are these force in? So you look and you see which quadrant the force in. This one is in the first one. All of the components are positive. This one here, the x, the second one, the x is positive and the y. Sorry, the x is negative and the y is positive in the second. Right? And the
Yes, sir.
last one, it runs between them, which you know that for the y must be negative going down. Right? And it
Yes,
has
sir.
no x component. So that's supposed to be easy. So you'll have three components for the y. And you'll have for the y-axis, some of the forces in the y, and you'll have two for the x-axis.
Excuse me, sir. For
Mm-hmm.
the angle for TCA, is it 30 or 38?
30. Sorry, let me fix that. 30. Thank you. 30. Right. Mm-hmm. Are you ready to tell me what to write for the x? We have been doing a lot of component work.
Sir, is it never mind.
Listen, me, how you guys making it so hard? You need to
Sure, because
stop doubting yourself, man. This is positive x, this is negative x. This is positive y. Right? It's the same principle. This is negative y. It's done. You know which quadrant they are in. Give me some components, man.
You have negative TCA
Negative TCA.
plus positive TCB.
What about the component? What about the trigs, boss? Or you
Um,
eat off the trig? What to the trig?
you
The
have
component, I must have a trig, boss.
30,
30, sir.
Huh?
Cost 30.
30.
Yeah, so you eat it off.
And then positive TCB cost 40.
Stop doubt yourself. And what else do I write here? I'm gonna put equal. What do I put equal what now?
0.
So
Zero.
it is equal
Right.
to
So that is
11.
now equation 1. Alright. And then you're gonna do the next one for me. Sum of the forces in the y equals 0. Because the system is in equilibrium. Alright? Alright. You can start any way you want. Your choice. Give me some components now.
You have TCA sine 30 plus TCB sine 40 is equal to 10. Yep,
It's not 10.
plus 10.
You see
It's
the
equal
workout
to
here?
98.1.
How much?
Is it
98.1.
Yeah,
you're
98.
saying 9 equals to? What's this component here? What's the one down here, the tension down here for the weight? What's the component? What's the value for
O
you
times
don't even
gravity.
call it T. Is this going to be plus T or minus T?
minus
In the
T, sir.
equation.
Minus T.
So minus.
Right? But you know that T is really equal to what? 98.1. All right?
Yes.
So it's equal to that. So now this is equation 2. All right. So now somebody gonna tell me how to solve that. All right? This thing not scrolling. So you're gonna tell me how to solve that now. All right? Come now. Tell me how to solve it now. What will be your first step?
You'll have to make an equation 3.
From which one? From which one of the equation you'd use? Which one will you use?
The first one, sir.
And then what you'll write? What is the first statement you'll write in making that equation? You could rewrite it. All right. And when you do that now, what else would you write? So you write that down first, because you're going to formulate it now. And what would you write next? So you could basically say that TCB cos 40 is equal to TCA cos 30. You couldn't say that? Huh? You don't say that? Couldn't you say that? Bring the negative one over to the positive. All right? And
Yes,
then
sir.
now, so what you will do next? Here. It's not finished. What will you do here?
Divide cost 40 on both sides.
So you're going to transpose for TCB. So in that case, you can choose to separate the product here. And Anything you do on one side, you have to do it to both. So you'll get here now TCB equals to TCA cos 30 upon cos 40. Can somebody work that out and tell me what's it so you can simplify it? And this is now equation what? This is essential now is equation 3. Right? And you can simplify that. Simplify it and give me the simplified version, please.
One point
Yeah,
one
1.1.
one.
All right, let me erase that and fix it up. Hold on. 1.1.
3-1.
Let me check your work here. Don't think I don't have a solution around here. You see, I should have that one. I just saw it this morning. Okay, I thought I have it here with me. No, 1.1 what?
3-1.
31 TCA. So that's a simplified version of it, eh? That make life much easier for you, right? It could, right? But that's typically one approach, right? Another way is that you could leave it as is up into equation 3, right? If you choose to leave it up here, TCA times cos 30 upon cos 40, right? If you choose to leave it as is, then it is okay. All right, you're now going to substitute. Since you don't say it, let me say it. You're going to substitute equation 3 in equation 2. All right, so let's proceed to do that. So equation, so that goes, anywhere you say TCB, you're going to put that expression there. So it is TCA sine 30. All right, and you're going to take this, take TCB. Where's TCB? It is beside it, eh? See it right here now. Let me just see it right here. So we're going to put it right here. All right, so that's what I'm doing. That's what I'm looking on, and then we're going to put it in. Or you could do it from here. Well, yeah. So that's basically where it is. I'm going to implant it now. So implant it, it comes TCA cos 30 upon cos 40. All right, not finished. Sine, let's go back. Come on, right, where are you? Sine what? 40, right? Now, when you do that, equation not finished. Minus, remember this t here? You know the value of the t. Remember it was 91, 98.1, that's all? Equal to 0. Remember that?
Yes,
That the
sir.
t is equal to 98.1, right? So the person don't look surprised. The t is the weight, yeah. So right there, you can rewrite this expression and it becomes TCA sine 30. I think I want to rewrite that. Right? Plus, now, as you look over here, let's an observation here. Do you see anything here? Do you see anything formulating there? Just a question. Do you see anything there? You could actually do a number of things here. Right? But I'm just pointing it out. But I'm not going to say anything. I'm just pointing it out. Right? So look, the approach here, in this way, if you take it out and put it as a tan, it's gonna give you a problem. Right here instead, well, that is really a tan, but we're not going to take it out. What I'm going to do instead, not going to make it complicated, we're just going to work out the numerical value for all of that. So work out the numerical value for all of that for me, please. Can somebody do that?
0.727, sir.
Let me confirm. So you get, so it's technically tan 40 times cos 30. It's the same thing. How much you say you got?
0.727, sir, but I used the 1.31 instead of 10.
So that is
Oh,
typically
yeah.
what you get for all of that. That's what you got?
Yes, sir. Yes, sir.
So whether or not you do cos upon, because look, what did I write here? Did I write something correct? It is cos upon cos 40, right? Is it all of that? That should give, we know that that will give over 1.131 times sine 40, right? So you work out all of that and it make life easier. So what you'll have right here now is 0.7266 TCA minus 98.1, right? Equals to
Sir,
0.
if you use 1.31, you get 0.72699 instead of the 0.726, sir.
Let's check it. Let's check. I'm going to check back the working. All right, let's check back the working. Let's check it back. Because I use tan times cos 30. Because that part in the red is really tan 40, you know, time cos 30. So I'm going to do it the long way. Cos 30 divided by cos 40. I'm getting 1.305 times sine 40. So I'm getting the same thing pretty much. Yeah. Don't run off too early. I get the same thing pretty much. This can run off to 7. That figure there is 7. Right? And so the first one can be simplified as to 0.5 TCA plus 0.7267 TCA minus 98.1. And that's finished. So look, all you need to do is add them together now to 0.5. So you add 0.726 to, because remember the two of them are common. So you add them together and it should give you 1.22 67, right? TCA, which is equal. You carry the force over, comes positive, and then from that you calculate your answer, which is TCA now is equals to 98.1 divided by 1.2267. And how much you get from that now?
79.97.
Right. Typically that is 80, eh? 80 approximately, right? And then you go now again. What do you do after this? You're gonna substitute back the value of TCA into equation 3. Remember what is equation 3? Is TCB equals 1.131 TCA, which gives you imply that TCB is equal to 1.131 times what's TCB value? 80, right? So what's the value there?
$90.48.
You sure? Hold on, let me check that. Okay, so you get 90 0.45 newtons, right? So all of this is in newtons, right? So everybody understand that now?
Yes, sir.
Mm-hmm. All right. Any question? Any question? That is it. That is a
Sir,
bit. Yes. Mm-hmm.
for the 1.131 times 80, I'm getting 90.48.
Which one?
That one right there.
Yeah.
The 1.131.
Mm-hmm.
Yeah.
90.45 or somewhere there. Yeah, that's all right. Little decimal off. All right. The next one. Next question. This one. All right. First of all, let me guide you. You're gonna draw your free body diagram of the system. So you must draw your free body diagram. So if you don't draw your free body diagram, you're going to misguide yourself. So you have one force there. You have another one down here. All right. And then you have another one like somewhere up here. All right. And then you have one coming down here. And you have one coming down here. All right. Let's draw a line representing the axis. That is so wrong. Let's try that again.
Excuse me, sir, I have to leave for my next class. When will the recording be posted?
Well, yes, I will try and post the recording. All right, question. So you all have to leave. So look, I'm just guiding you. So you're gonna try this. So look, you have to leave for your next class. Look, so see it here now. You're going to just draw these and you're going to do them. So you have to do two sets, just like what you did a while ago. But this time around, you have to do it 2 times. All right, so you're going to decide which one based on the information that you have. So you have information for this one. This is 30 pounds coming down. So you go with the one that you have most information for. This is 15, right? So that's as a guide, so you can start it. And what else do you have? So you have that. You have this is 30. You put in it and you draw a proper free body diagram. Label your diagrams first so you can know where your forces are. All right. Once you have done that, you could say that your tension here is CD. Coming from the root here and the direction, you label them based on the direction. So this is BA. And this one here depends on where the tension is going and where the thing is pulling, right? But as I said, so it will have two. So you could say when it is coming this way, it's that, but it's reverse on the other side, right? So typically you split them up, right, and approach it that way. So you can choose to do two side first, and then you move on. So you separate this now. You separate that now into the side. Suppose you decide to go with the left side, you could redraw it for clarity, right? Redraw it and decide, and you know exactly the side that you're working on. So you redraw it, and you know you have your horizontal. This is 15. Is it writing or is it drawing? So that is 15, right? And this is 30, right? Right. So that is 30. So you just redraw it and do it, right? And this one is
Sir, question.
30. What?
Question, sir. For the weight of E, you'd have to convert that 30 pounds to kilograms, right?
No, we didn't even ask you to do that. You can make it stay in that. we're not asked to do any conversion. All they ask you to do is to find the weight. So you don't do things that they don't or we don't ask you to do in the question. It just asks you to find the weight. Doesn't matter you find it in pound or newtons. You can find it in imperial as long as we don't ask you to convert. Right? Because the unit that is given in is quite okay. And so you're labeling here, you know that this you'll be finding TCD, and this one you're finding TCB. Right? So it's two, you could actually put that there. Right. So when you're doing it from either side, so you're doing it this side, this is the system that you're using, this one. And then the other one, when you're doing it again, similarly, you go, right? And you go, right? So it is going to be B, C this time, and this one is A. And the same thing applies. So you would have found CB already now, you know. When you finish the first one, so this is step 2. Step 1 would give you CB, right? So step 1 will give you CB. So now that you get CB, you could proceed to find TBA, right? Which is you want, this is a weight that you want that you don't have here. What they call it? TF, if you want to call it that. Right? So you would have all these angles here, so you can calculate them. So if that one is 15, this one is 15 too. You see that? This is a Z angle, so this one down here is 15 too. And this one is 45. Right? So you just go ahead now and split them up in parts and do it. Right? So you could approach this part first. Right? Right? So you just simply go and write the forces in your x equals 0. So you can all finish this. Right? So you just say that. So this is going to be what now? Minus T CD cos 30 plus T CB cos 15, right? Right, equals to 0. And that one is done. And the last one for this one now, f of y equals to 0. This is simply going to be what now? T, so you're writing it for the top now. So it is going to be TCD sine 30 plus, is it plus? It's minus, sorry. Minus TCB sine 15 minus 30 equal to 0. So, and that is now equation 2. And you do it just like how we did the other part. Do your substitution with equation, transform equation 1 into equation 2. After you finish that, you take equation 3, substitute it back in equation 2, solve for them, and then now you will get TCB, which is common to both expressions. So this is a TCB, but you would get TCB from, see here, so TCB here. So you'll have calculated from this system. You put it here, whatever value it have here, all right? And then now you only will have how many unknowns you're gonna have there. So now, so you have one known, and you'll have 2 unknowns here. You'll have that one and that, all right? And pretty much you'll be good. Did they give anything else? Let me just check if what else they gave. So they said that is that, right? So you have one known and you form. So you'll have to form another 2 equations over here. So you'll have 2 unknown. TBA is unknown and TF is unknown. So you form 2 system equations separately and approach it. All right. So you can work that and tell me what you'll get. All right. So we typically finish. Everybody put their name in the chat.
Yes, sir.
Make sure you put your name in the chat. So hopefully next week I'll be able to come out. All right. Um, so you all need to solve that expression and tell me what you get. You all have class now?
No, sir.
Work the problem and tell me what you get.
You want a step by step, sir, or do you want just the final answer?
You can tell me what you do to this part here. Tell me how you're gonna solve it.
Okay, so for the first equation, you set it so because it's minus and plus, you set it so that cost TCD cost 30 is equal to TCB cost 15.
So hold on, let me take it. Tell me what you did with the first expression.
Because it's minus TCD plus TCB, and that gives you 0. That means they're equal to the same thing. So you
Pretty much.
can
So
write
you could pretty much
Yeah.
write TCB cost
Mhm.
15 equal to TCD cost 30. Not true?
Yes,
Is that
sir.
right? Okay. When you do that now, what else are you going to do now?
Then you move over the 15 over the equal sign, and you divide cost 30 by cost 15.
What are you transposing for? Which one?
TCB, sir.
TCB. If that is so, you divide by. So you're going to divide that expression by cos 15. And so you would get that TCB is equal to TCD cos 30 divided by cos 15. And that will give you a simplified version. So what you have now? Cos 30 divided by cos 15.
To 3 significant figures, sir. That's
Four. Give me four.
0.89.
Four or five.
To 4?
Or
To
five.
5?
Yes.
0.9658.
0.9.
6, 5, 8.
And that is
Oh, no, that's 4. I think I'm missing a digit. Hold up. No, 0.89565. 0.89658, sorry.
0.89. That's it?
Yes, sir.
All right, you all check that, please. And that now is equation 3. What are you going to do with that equation now?
Or you're going to substitute it into the second equation, sir.
All right. So I'm going to check your calculation. Okay. All right. It's correct. All right. So you're gonna substitute equation 3 into equation 2. How are you gonna do that now?
Where we see TCB, we're going to replace it with TCD cost 30 over cost 15.
Okay. So that means that you could write that writing from the second equation you have. So you put your statement first. Substitute equation 3 in equation 2. And then you proceed. All mechanical statement, eh? So somebody can follow your process, what you're doing. So this is sine 30. Don't make anybody assume anything. So this becomes 0.8965 TCD sine 15 minus 30 equals 0. And so from that now, when you solve it, what are you getting? So essentially, the sine, you know, sine can be really written is really 0.5. So this is really 0.5 TCD minus 0.89658 TCD, right? Sine. But by the way, we can actually do some clean up here. So rather than writing this 2 times, multiply sine 15 by that number for me. How much you getting? So you're getting 0.232 1 TCD minus 30 equals to 0.
Yes,
And
sir.
that pretty much gives you minus 0.265. No, it's not 5, it's 7. Sorry. 7, hold on. 7, 9, 5, TCD, right, minus 30 equals 0. So your TCB is going to come over, it's to become positive.
Sir, why is it minus?
Why? Why? It's not
If
minus.
it's
Sorry, it's plus. Sorry,
oh,
it's plus. It's plus. Thank you. All right, 0.267. Because the procedure that I use, that's why I mistakenly write it. I realizing that I'm writing down the minus sign. Based on what I had in my calculator, I just turn it into minus in order to get the correct answer. And therefore, that gives you what now? Inverse. So what you get in there as your answer?
111.96.
That's what you got?
Yes, sir.
And it was
Yes,
what?
sir.
It was in pounds, right?
Yes, sir. It will be.
All right. So now you should be able to put this value here. Because you know this value. 1. How much you want to round that off? Well, you can pretty much work with 1,
Yeah,
1,
112.
9. You can work with that pound. Right? And then you have that to start off with. Everybody see how I got that this angle down here is 15 is a Z angle from up here. So if that one is 15 up here, so this one must be 15 because it's 2 parallel line and a line crossing it. So it's opposite and corresponding angles. That's what it is really. Right? So, and this one is 45. So you pretty much just draw it up, just expand the view so you can read it. So you're gonna get your components again and do pretty much the same thing. So you all can solve the rest of that. All right. We will by the end of the week we'll post the solution. Righty. So please finish that up. Ball is in your court. Today is what date again? The 30th. Wow, time is flying. Kerry was here? No. Yes or no? I'm calling the names. Kerry is here?